Hello everyone. So let's solve some more problems based on integration, that is the subtopic integration by substitution. Okay. So now here 1 upon x minus a and sine x minus b is given. I want to reduce this denominator. Okay. So I have to multiply something in the numerator, right? So that something should be in the form of sine of these two terms. Okay, so if I multiply both numerator and denominator by sine a minus b, okay, let's see what happens. Minus b sine minus b dx. Okay, now this the term which is in the denominator I can take outside. Okay, now I have to write this term in terms of this x minus a and x minus b. So how I can write a minus b in the form x minus a and x minus b? So a minus b. Okay, I have to add x and minus x, right? So here already minus sign is there for b. Okay, so I can write x minus b. Okay, one of the b is used. Now I have to write x minus a such that when this a comes outside it should be positive. So I have to write here minus sign, right? So that what happens, x minus b minus x plus a. So this and this gets cancelled and we'll get a minus b. Okay, sometimes you have to do such adjustment, okay, to simplify the problem. Okay, so a minus b I can write it as x minus b minus x minus a. Okay, now it's easy. So take this sine a minus b outside because it is a constant, and you have to integrate this term. So you have to expand this sine x minus b minus x minus a. So this you have to use sine a minus b formula. Okay, so what is sine a minus b? Sine a into cos b minus cos a into sine b, right? Now I will write this denominator, separate this. X minus a sine x minus b, and then there is a dx. Okay, so you can cut the like terms. This gets cancelled and this gets cancelled. Did some mistake. Oh, this is x minus a. Okay, so this and this gets cancelled, so you will get 1 upon sine a minus b integral cos x minus a upon sine x minus a, cos upon sine which is cot x minus a, minus cos x minus b upon sine x minus b which is cot x minus b dx. Now you can integrate this two using the formula for cot. So use that. So this is cot is log of mod of sine x minus a, right? And the derivative of x minus a is 1. Okay, so no need to write it. Minus log sine x minus b plus c. Okay, now you can use the properties of log. This is log a minus log b, so you can write it as log a upon b. So it will be log sine x minus a upon sine x minus b. Okay, that form also you can write. Here another example. So here it is given 10 raised to 4 root x sec square root x upon root x. Okay, now you have to choose the term which you have to take it as t. Okay, so you have to first see if the derivative of that term exists or not. Okay, if I take 10 as t, the derivative of 10 will be what? Sec square, right? So the derivative is there, so we can take t as 10 of root x. Okay, so dt will be what? 10 root x sec square root x, and you have to take derivative of root x, which is 1 upon 2 root x, right? dx. Now you substitute, so our integration will be 10 raised to 4 root x means t raised to 4. Okay, sec square 1 upon 2 root x dx. So this whole term is there, so you have to take 2 that side, so it will be 2 dt. So integration of t raised to 4 is 2, you have to take outside, t raised to 5 upon 5 plus c. So whatever t you have taken, you have to write over there 10 root x raised to 5 plus c. Okay, let's solve this. So x cube sine tan inverse of x raised to 4 upon 1 plus x raised to 8 dx. Okay, first you decide which term you have to take it as t. Okay, so mostly we take the term which is in which is in the bracket or which is inside a function. Okay, so that it becomes easy for us to evaluate it. Okay, so if I take tan inverse x raised to 4 as t, then this term will become sin t, and then we can directly integrate it, right? So tan inverse x raised to 4 I am taking as t, and I've seen that 1 upon x raised to 8 is there. So this is the derivative of tan inverse. What is the derivative of tan inverse of x? It is 1 upon 1 plus x square, right? So it's over there. If I take this as x raised to 4, then automatically this gets 4 into 2, which is 8, right? So t, if I have taken tan inverse x raised to 4, dt will be what? 1 upon 1 plus x raised to 4 square dx into derivative of this term, that is 4x cube dx. Okay, so can make it as 4, you take that side because we don't need 4 here. So dt by 4 equal to x cube dx upon 1 plus x raised to 8. Okay, now you don't have to square here. Okay, some students make mistake, they write 4 square 16. Okay, you have to use laws of exponents. A raised to m raised to n is a raised to m into n, so 4 into 2 becomes. Okay, now you substitute, so integral x cube 1 plus x raised to 8, this becomes your dt by 4, and this is your t. So sin t dt by 4. So 1 by 4 you take outside. What is the integral of sin t? It is cos t, right? Minus cos t plus c. And then you have to substitute t. Yes. Okay. Let's solve this. So here you have to first expand. So sin x plus alpha, you can use sin a plus b formula. So integral 1 upon root of sin cube x sin a plus b formula. So sin x into cos alpha plus cos x into sin alpha, right? Dx. Now can you take sin x common from this? Think about it. Yes, you can. How? If I write here, if I take out sin x from here, okay, so here I need sin, right, to take that sin outside. So I can multiply sin x and divide sin x here, okay, so that I can take out this sin x and this sin x common. So this will become sin raised to 4x. Now why I have done this, I will let you know. See, so first you write this cos alpha plus, now this cos x upon sin x becomes cot x, right, into sin alpha dx. If this is raised to 4, I can easily cut this root and raised to 4, okay, so I can take this outside of the root. So this becomes 1 upon sin square x, correct, and this is your under root term cos alpha plus cot x into sin alpha, okay, dx. Now take this cos alpha plus cot x into sin alpha as t, okay. If I take this as t, what will be my cos alpha plus cot x into sin alpha, right? So dt will be what? Now cos alpha is a constant term, so this is 0. Cot x is what? Cot x is minus cos x square x and into sin alpha, and this is dx, correct. This is your dt. Now this 1 upon sin square x, I can write it as cos x square x. So this becomes our dt, and the term which is below becomes our root of t, okay, minus root t. So I can write integral minus, one more term is there, that is sin alpha, okay, sin alpha I can write here cos x square x, so dt upon sin alpha, so this comes outside, that is 1 upon sin alpha, minus sin also you take outside, so this becomes dt upon root t, okay. So 1 upon root t, so t raised to minus half, t raised to minus half plus 1, that is t raised to half root t plus c. This is the answer, and then you have to write t over here, okay, whatever t you have taken you have to write. Let's solve this. Integral sin x upon root of 1 plus sin x. So First you see if you can separate the denominator. Okay, can write this as 1 plus sin x minus 1, right? So this will become root of 1 plus sin x upon root of 1 plus sin x dx. So this root will go in the numerator, that is, if I multiply this by 1 plus sin x and 1 plus sin x root, okay, that is, it is like this, 1 upon root 2 suppose is there. So if I multiply root 2 over here, then this will become root 2, and here the same term is there, right? So this and this gets cancelled and you get a term in the numerator. So I can directly write this as integral root of 1 plus sin x minus 1 upon root 1 plus sin x dx. Okay. Now can you use something here which I have done in half angle formula? This type of problems we have solved, integrals, right? This one I can write it as sine square x by 2 plus cos square x by 2, right? And this sin x I can write it as 2 times sine x by 2 into cos x by 2. So this whole term becomes sine x by 2 plus cos x by 2 the whole square, correct? So you can directly write here integral root of cos sine x by 2 plus cos x by 2 root, right? So root and square gets cancelled. So you have to integrate this. This is easy, right? Now this term is remaining plus sin x dx. Okay, we'll integrate first this. So this I can write it as sin x by 2 integral of this is minus cos x by 2, and then you have to divide by derivative of x by 2, which is half. Okay, plus cos x by 2 integral is sin x by 2, and you have to divide by derivative. Okay, this is over. Now only thing is I have to solve this. Okay, let's solve this separately. 1 upon root 1 plus sin x. I'm writing this as I2. So 1 upon root 1 plus sin x. Okay, so I can write this as 1 upon sin x by 2 plus cos x by 2, right? Okay, now this is something like sine into something plus cos into something. Okay, so I can use formulas like sine a plus b or cos a plus b. Okay, so I'll multiply and divide by 1 upon root 2. Okay, so 1 upon root 2 I'm multiplying and dividing, means multiplying in the numerator and also in the denominator. So this will become sine x by 2 into 1 upon root 2 plus cos x by 2 into 1 upon root 2. Okay, dx. So this 1 upon root 2 I can write it as cos of pi by 4, right? Plus cos x by 2, and this is our sin pi by 4. That is sin pi by 4 and cos pi by 4 is 1 upon root 2. Okay, so this becomes our sine x by 2 into wait, this I can write it as sine pi by 4, right? And this I can write it as cos pi by 4. So this becomes cos a minus b formula. Cos a into cos b plus sin a into sin b. Okay, so cos a is your x by 2 and b is pi by 4. So I can write this as cos x by 2 minus pi by 4. Okay, which I can take in the numerator. So this becomes sec x by 2 minus pi by 4. I will write here. So 1 upon root 2 is outside. Integral sec x by 2 minus pi by 4 dx. Okay. So integral of sec is log of sec of these two terms plus tan of these two terms, and you have to take the derivative of x by 2 minus pi by 4. So derivative of x by 2 is half plus okay. So next one is 1 upon x plus x log x dx. So I can take x common in the denominator, right? Can you use here t, that is substitution? If I take t as 1 plus log x, what will be dt? This is 0. Log x is 1 by x and dx, right? So I can use this. So I can write here integral 1 upon x is our dt and this is t. So this is log of mod of t plus c. So t I have taken 1 plus log x, correct?